Hello everyone. In this lesson we're going to be continuing with what we did in the prior lesson on substitution, but we're going to be looking at more kind of a combination of reviewing the basics of the skill and then also applying it to solve word problems. Recall that this is just one of the skills that we use throughout the bigger theme of the chapter, which is finding where two lines cross. We started by first graphing it. Graphing, it's a good first tool to get an idea maybe where an answer possibly could be, but then we found a downside of graphing is it might not always cross a perfect integer intersection, and so we need more precise tools, and that's what substitution was. So to get us kind of warmed up, I'd like you to try to solve this kind of riddle that you'll see sometimes on like social media platforms. They tell you here that 2 bags plus 3 coins is valued at $140, and 1 bag is equal to the same value of 2 coins. So can you tell me what the value is of each bag and of each coin? The method that you're kind of using to inherently solve this riddle is what we call substitution in mathematics. So if you would, pause the video now for maybe a minute and a half or 2 minutes. Give yourself that long to try, and then unpause it and come back and see how you did. So pause the video now, please. Okay, here's the idea. 2 bags plus 3 coins is equal to $140, but I know that 1 bag is equal in value to 2 coins. So what I can do is, instead of having 2 bags here, I can replace each of the bags with 2 coins. So 2 coins here, and then instead of putting a bag here, kind of move it out of the way, and I'm going to place 2 coins. That is the substitution step. We're essentially substituting in 2 coins for the bags, for each bag. Now I've got what, 1, 2, 3, 4, 7 coins is valued at $140, which means I've got 7 coins is equal to $140, which if you divide by 7, you'll discover that each coin is valued at $20. If each coin is valued at $20, then that means each bag, and this is the last part where once you have the value of one of them, you can substitute in to either of the original equations. The bottom one is very easy because 2 coins, 2 times 20 is going to be 40. So each bag is valued at $40. Each coin is worth $20. That little simple idea that you use to solve those types of riddles is called substitution mathematics. It's the same fundamental principle. So hopefully if you can follow this, you can follow it when we're using variables instead of pictures to represent our unknown quantities. So if you would please have out your note packet to follow along. It should say something about the second day of solving by substitution and using it to solve or write word problems. We're going to start with some examples that are just equations of lines to find where 2 lines cross, and then we'll eventually work towards setting up our own word problem equations and solving those word problems. The steps that I would suggest that we use when substituting is to first solve for a variable, get a variable all by itself. So if I look at these 2 equations, there's technically 4 choices. I could get the top y by itself, I could get the top x by itself, I could get the bottom x or the bottom y by itself. 2 of them are much, much easier than the other 2. I would say the top y and the bottom x are very easy to get by themselves. The top y you would add 2x over, the bottom x you'd subtract 2y over. It doesn't matter which one you do. I would guess most inherently would probably solve for the top y by adding the 2x over, and then you get 3 plus 2x. You cannot combine that to make 5x. 3 1s and 2 x's are not like terms. So there's step 1, is to solve for a variable, get a variable all by itself. Step 2 is to substitute that variable into the other equation. So what we're going to do, this was when we did like the 2 coins is equal to 1 bag in the riddle, is I take this and I'm going to substitute it right down here. That would be step 2. It will then look like x plus 2. Instead of writing y, I'm going to use the clue that I had about y, and the clue was that y is equal to 3 plus 2x. And that's step 2 of substituting. Step 3 we're about to do is going to be to solve for the first variable. Now we're just back to first quarter, back in September, when we were solving equations, doing simplify, same side, solve. Simplify usually meant distribute first. So then I get x plus 6 plus 4x equals 11. I combine my like terms of 1x and 4x, that makes 5x's, so I get 5x plus 6 equals 11. If I subtract 6 from both sides, I get 5x equals 5. If I divide by 5, I then get x is equal to 1. So I have half the point right now. I know that the lines are going to cross at 1 comma blank. I don't know what the y coordinate is, but I know that x is equal to 1. Now I'm going to be on step 4. Once I know the value of one of the coordinates, I plug that value into either of the equations. So I can substitute it in. I could do the original top, but that would be one extra step when I already solved the original top one for y. Or I could do the bottom one. I could put 1 in for x and then solve for y. I think this one right here is probably the easiest, so we're going to substitute 1 in for x there. So y equals 3 plus 2 times 1, and that's going to give us 5. And then step 4 would be to check. Plug 1 in for x, 5 in for y, and make sure that it makes both statements true. I can show you the picture of the two lines and verify with you that indeed those two lines cross at 1, 5. So we did it correctly. So there we go. There's all 5 steps. I'd like you to try a simple one where we're doing with just equations for lines, no word problem one. So see if you can follow the same format that we just did. Solve for the variable, get that variable substituted into the other equation, solve for the first variable, use the value you found for the first coordinate to get the second coordinate. So you tell me where those two lines cross. If you pause the video now, let's give people maybe 2 minutes. Once you get your answer, maybe check with the neighbor. So pause the video now for 2 minutes, come back after everyone's had 2 minutes to try. Okay, here we go. I'm going to show the steps pretty quickly. I would probably get the best choices is top x. All the other ones would include a division step, so we're going to avoid doing more work than necessary. So there's the first step. Then I'm going to take this and I'm going to substitute it in for x in the other equation because my top equation says x equals. So I got 4. Instead of writing x, I'm going to write negative 6 plus 2y. Then I have plus 6y equals 4. I need to distribute. I'll get negative 24 plus 8y plus 6y equals 4. Combine these like terms, make 14. Add the 24 over to the other side. I get 14y is equal to 28, which means y is equal to 2. If y is equal to 2, I can then plug into the top equation to get x equals negative 6 plus 2 times 2. And that's going to give me negative 6 plus 4. So my x coordinate has to be negative 2. So my point is going to be negative 2, comma 2. If you graph it, you will see that the two lines cross at negative 2, comma 2. So hopefully you got it correct. Now what we're going to do is we're going to move on and we're going to start to use our idea of substitution to solve word problems. And the only way to get better at those type of ones is just to practice them. They're not too difficult once you've seen a few and you kind of understand the structure. So this one says an investor is looking to purchase a number of stocks of company A and company B. He wants to own 200 shares and has $4,000 to invest. How many shares of each stock should the investor own? Step 1 is to define our variables. Our variables are always going to be the items we don't know that will allow us to solve the last question. The last question is how many shares of each stock should the investor own, so that should be our variables. X will be number of shares of stock A. Y is number of shares of stock B. I should probably talk a little bit about the background information of this because maybe some people don't know exactly what stock and shares mean. So what happens is when a company needs to raise money, they will sell part of the company and they call that shares. So when they sell part of the company, then you own part of the company. So as the company becomes more valuable, the piece of the company that you own becomes more valuable, and then you can share it for, then you can sell it later for a higher value than you bought it for. So that's what happens when companies go up and split themselves into different stocks. So company A is selling parts of their company for $9.50. Company B maybe is worth more because their stock is $27 a share. So you buy part of the company, you own part of the company. As the company does better, then you can sell your shares at a later time for more money. That's how investing works. Now we're going to write two equations. So the two equations need to come from the clues that they gave us. So it says an investor is looking to purchase a number of stocks in company A and company B. This first sentence is what allowed us to define our variables really. Now the next part, it says he wants to own 200 shares. So there's one equation. We know the number of shares in stock A plus the number of shares in stock B, which was Y, has to equal 200 shares. Then it also says that he has $4,000 to invest. Well, stock A is $9.50 for each one. So $9.50 for stock A plus $27 for stock B has to total the $4,000 that he is able to spend. There's my two equations. Now my job is to solve those two equations. In order to solve, I need to get one of the variables by itself. The bottom x or the bottom y is not a good choice. You'd have some subtraction and division that would lead to either decimals or probably fractions. It's, one of the two, however you decide to write it. Top one would be a much better choice. You can either get x or y by itself. It doesn't matter. I would guess most people, well, I don't know, maybe 50-50 split. I'm going to get maybe x by itself. Subtract y over. So then I will have x is equal to, can I actually move this up and save some space? No. Okay. X is equal to 200 minus y. Now that's step one. I got one of the variables by itself. Step two is to take this and substitute it into the other equation. I then get $9.50, and instead of writing x, I'm going to write what x is actually equal to. X is actually equal to 200 minus y, because however many shares of y you buy, x will be 200 minus y of them, plus 27y is equal to 4,000. Now you'll notice my equation only has y's to deal with, so I can solve it. I solve by distributing, so distribute. You might want to grab a calculator. 9.5 times 200 is going to give us 1,900, so 1,900 minus 9.5y plus 27y has to equal 4,000. I subtract 1,900 from 4,000, and that's going to leave me 2,100. Negative 9.5 plus 27 is going to be 17.5. And then I divide both sides by 17.5. And I will find that there were 120 shares of stock B. Now I need to know how many there are of stock A. Well, you'll recall there were 200 in total, so x will be 200 minus y. And we already found that y was 120, so x has to be 80. So he bought 80 shares of A and 120 shares of B. I'm going to scoot that over a little bit so it looks more like a last step. There we go. And that's how you go about it. You realize very similar steps to what we did before, only difference is that we have to set up the equations for ourselves. Okay, so we will try one more, then I'll have you try one. This one says, the French club sold tickets to the crosstown basketball game. At the end of the game, they had sold 645 tickets and made $2,795. How many adult and student tickets did they sell for each? Well, the question at the end says how many adult and student tickets, so that's the thing I don't know, so that has to be my variables. So x probably be number of adult tickets. You always need to define what your variables are when you're solving. Y has to be number of student tickets. And then I go back and read the paragraph to pull out the equations. The French club sold tickets to the crosstown basketball game. There's no equation there. That's just what helped me eventually write the variables at the end. Then it says, at the end of the game, they sold 645 tickets. So that means the number of adult tickets plus the number of student tickets has to be 645. That's our count equation. Almost always when working with these, there's usually going to be a count equation, and then there's going to be a cost equation. The cost equation is coming up next. It says they made $2,795. Well, adult tickets were $5 for every adult, plus $3 for every student, and it was $2,795. Now I'm on the last part where I actually need to solve it. I need to get one of the variables by itself. So probably the top x or the top y would be the good choice. Last time we solved for x, let's solve for y this time. So y would then equal 645. How do I get rid of a positive x? I subtract x. Now I'm going to take this y and I'm going to substitute this in for y in the other equation. So now that other equation, my cost equation, becomes 5x plus 3, and instead of writing y, I know that y is actually equal to 645 minus x equals 2795. Now I'm solving just like we were doing in first quarter. Distribute through. I get 5x plus 3 times 645. That's going to be 1935 minus 3x equals 2795. I combine my like terms. I have 5x minus 3x over here. That's 2x's plus 1935. I now need to subtract 1935 from each side. These will cancel each other out. I then just get 2x equals 2795 minus 1935 is 860, which if I divide by 2, I get 430. So they sold 430. X was adult, so adult tickets. And then to get y, I can use the fact that I already solved for y right before doing the substitution step. Y was equal to 645 minus x, but x is 430. So y then has to be, what is that, 215? And that would be student tickets. Maybe a lot of them already had a pass because it looks like they sold more adults. So there you go. Should add up to 615, and if you put it back into the money equation, you should find a total is $2,795. Very similar to the one we did right before it. Okay, I'm going to give you a chance to try one. This says a class of 1,900, or 1,000, a class of 195 students went on a field trip. They took 7 vehicles, some cars, and some buses. Each car could hold 5 students. Each bus can hold 45 students. I don't know why I have trouble reading that. How many buses and cars did they take? First, define your variables, then write 2 equations, and then go ahead and solve. So pause the video now for maybe 2 minutes. Give everyone a chance to solve it. After 2 minutes, unpause it to come back and see how to do it. So pause the video now, please. Here we go. The 2 things we don't know is buses and cars, so x might be number of buses. Y would be number of cars. Write 2 equations. Well, the first one was they took 7 vehicles, some cars and some buses. So they took 7 vehicles, some cars and some buses. So number of buses plus number of cars has to equal 7. Then they said each car can hold 5 students. So 5 students for every car, plus each bus can hold 45 students, so 45 for every bus, has to total 195 students. And now I go ahead and solve. Probably one of the top x or top y are going to be the best to solve for. Maybe x is equal to 7 minus y. Then I'm going to take that and I'm going to substitute it right in there. So I then would get 5 times parenthesis 7 minus y plus 45y equals 195. Go and distribute through. You get 35 minus 5y plus 45y equals 195. Negative 5 plus 45 makes 40y's. If you subtract 35, you get 160. Divide by 40, you end up with 4. So they took 4 buses. They said they took 7 vehicles in total, so that means x has to be 3. So they took 3 cars and 4 buses in order to get 195 students. And that's it. Thank you very much and have a good day.